Hey everyone, today we're going to be talking about solving inequalities, and our essential question today is how is solving inequalities similar to solving linear equations, what we just got done doing. You'll find when we solve the linear inequalities, you solve it as if it is a linear equation, just like we did before. Get rid of addition and subtraction, get rid of multiplication and division. You're just doing the order of operation in reverse. With our goal to isolate our variable, get it by itself on one side. The only thing you got to be careful of is if you multiply or divide by a negative, then you switch your inequality symbol. Okay, so if it was a greater than, it becomes a less than. But only if you multiply or divide the last step by a negative. So here's an example. Negative 3 times the quantity 2x plus 5, or 2x minus 5, plus 1 is greater than or equal to 4. So we did distributive property first, combine like terms, so we got negative 6x plus 16 greater than or equal to 4. Get rid of addition and subtraction, so subtract your 16 on both sides. Then here you'll see I highlighted it. When you divide by that negative 6, you have to flip your inequality symbol. So a greater than becomes a less than or equal to. So as long as x is less than or equal to 2, as I showed here on the graph on the number line, remember, a solid dot means it's equal to it, and smaller, less than is going to the left. That's where the smaller numbers are on the number line. So it's almost exactly like we did with linear equations. The other thing you'll find here too is similar linear equations. If you get an answer here where your variables cancel out, and you get something like negative 5 is less than or equal to 2, which is true, if it's a true statement, what that's telling you is that there's an infinite number of solutions. You could put any number in for x because it's going to cancel out, so it doesn't matter. If you got an answer like 5 is less than or equal to 2, which is false, then just like with the linear equations, that's telling you that there is no solution. There is no number you can put in for x to make that work. Okay? So you're either going to get it like this, or you're going to get a true statement, which means infinite solutions, or a false statement here, which means there's no solutions. Okay? Now our inequalities can also be written in what we call compound inequalities, where you get two of them for the price of one. Okay, two inequality problems, and they're joined by an and or an or. And I guess it's just best with an example. Find x. To solve, the problem is 7 is less than 2x plus 1 and 3x is less than or equal to 18. So we're looking for the number or numbers that solve this one on the left and this one on the right. It solves them both simultaneously. Nothing new as far as solving it. Solve both of the inequalities. You've got addition here, subtract it over. You've got division, it's a positive 2, so don't flip your inequality symbol. X has got to be bigger than 3. Remember, you eat up the bigger number. So we're eating up the x, so it's greater. So we're looking for numbers bigger than 3. Over here, divide the 3 out. X is less than or equal to 6. So since there's no equal here, it's a circle at 3. It's a dot at 6. We want bigger than 3, but less than 6. So any number between those two is a solution here. Okay? So it'll solve this one and this one. If you put 4 into here, you're going to get 8 plus 1 is 9. Is 9 less, or is 7 less than 9? Yes. If you put 4 in here, is 12 less than or equal to 18? Yes. So it solves them both. And then the opposite of that is the or. Okay, we want to find the value for w in this case that solves this side, this equation, or this equation. But it's not going to do them both together. You're not going to find one number that solves both. So here, subtract your 3, divide out your 7, you get w is greater than 8/7. 1 1/7. Add your 1 over here. Negative 13 plus 1 is negative 12. Bring down the 4w. Divide out the 4. W is less than negative 3. And what you see here is what's very common with these OR problems. They go either way. So either you get something that's bigger than negative or less than negative 3, or bigger than 8/7, bigger than 1 1/7. Now you can see why there's only one value that's going to serve 1. If you pick here, it's going to satisfy this equation, but it won't be true over here, and then vice versa. If you pick something bigger than 1 here, it'll solve this one, but not that one. So those are compound inequalities. So solving linear inequality problems is just like linear equations. Everything's the same when you solve them until the last step usually, where if you multiply or divide by a negative, flip the inequality symbol. Otherwise it's the same. You graph them like we've been graphing them. If there's a equal sign with your inequality, it's a dot on that number, and then shade it right or left accordingly, bigger to the right, smaller to the left. And if there's no inequality symbol, it's just greater than or less than, it's an open circle, and then shade right or left. Okay, hopefully that's been helpful. We'll go over this in class tomorrow and continue to do some work on this. All right, hope this has been helpful. Thanks, bye.